That is not an equation. Try again. And again, C in your book is an S for specific heat. Everything else I've seen is a C. You can write it either way you want, just know that they're interchangeable. So what of these variables do I have in this problem? Maurice, can you give me one thing I have in that problem?
You have your 133 joules.
So where would you put that?
With temperature.
Is joules a measure of temperature? How do we measure temperature? What units? Celsius. So does joules, is that Celsius? We couldn't do that. We know we need to go to the table for this one. What's our unit on mass? Grams. So what's our unit on Q? Joules. So maybe that 133 joules would work there. Do we know the mass?
Yes.
What is it?
5,000. No, 0.005.
It's just 5, Miss Sullivan.
kg.
5 grams.
Keep it in grams.
Yeah.
So this brings up a really important point. Remember we said when we're working with joules you have to convert to kilograms? But if you notice when we did the equation before for this equation, we said it was in grams. Can anyone tell me why I don't need to change that to kilograms? Yeah.
Yeah, specific heat is joules over grams times Celsius.
So the units for specific heat are joules over grams degrees Celsius, so that grams will cancel. If the units on this were joules per kilogram degrees Celsius, then it would have to be in kilograms. Do I know specific heat?
No.
That's what I'm looking for. Now, delta T is tricky. I have to do the temperature initial minus the final temperature, because it's change in temperature. It's what you start with compared to what you end with. So what temperature did this substance start at?
25.
25. And what did it end at? What?
55.
So before you type any of this into your calculator, is your number going to be negative or positive?
Negative.
I want you to type this into your calculator. I want you to get an answer, and I want you to tell me why it would be negative and maybe what we could do to fix that. So look through your notes on chapter 6 and figure out where these negative things come in. Grace, do you want to? Yeah.
Sullivan,
Yep.
where are you calculating again?
Oh, I made a boo-boo.
What?
That was my fault.
What?
Totally my fault.
Final minus.
I'm jeez, you're angry.
Are you serious? Wait, what?
Well, that's why. So I went back and read the problem. I'll justify it for you. Okay, so I went back and you want me to justify it on camera? That would make you feel better.
Then do that whole scene over.
Yeah, redo. Grace, are you still recording? He's already mad at me for moving. Okay, so here's what I did to figure out that I totally made a boo-boo. It's final minus initial because it is changing temperature. I don't know why I thought it was initial minus final. But here's why. If you get an energy that's a negative, he's still angry at me for moving. If you get a negative energy, what does that tell you? Did you release energy or need energy? I released energy. So if you look in this problem, is that substance releasing energy or does it need energy? It needs it because it's getting hotter. I know I have to add energy, so I know this positive 133 is going to stay positive. So that means my temperature change, it should end at a higher temperature than it starts. If anything cools down, say I started at 55 and end at 25, what's going to happen to my Q then?
Negative.
It's going to be negative because I'm releasing energy. What's that called? If heat is exiting the system, it's exothermic. If heat is entering the system, endothermic. I apologize for the boo-boo. Does anyone have an answer to this problem?
Yes.
It's AO. So what'd you get as the number?
0.89.
0.89. And Carrie, I heard you say that you thought that was aluminum?
Yep.
How do you feel on specific heat?
Pretty confident.
Okay. Do you want to